Hello, everyone. A very good evening to all of you. First and foremost, if my voice and video both are clear, please let me know. Great. All good? Wonderful. So let's begin. So today we begin with our sessions on science and technology, where we'll discuss about the various aspects of science and tech and something which is important from both prelims and mains perspective. But before we jump onto our chapters and try to understand the various aspects of science and tech as a subject, we'll have to first understand the strategy, a basic strategy about this subject, how to go about this subject, the various facets of this subject. So this is where we'll begin from. And then when we start with all our chapters one by one, we'll try to cover each and every aspect of every chapter that we have right here. So let's begin with the basic strategy. Now, before I start, I'll also tell you about something that, for example, you have the chat and you have, if you have any doubts, if you want to ask anything, you can always do that. But I'll not always be looking at the chat, but once in a while, whenever I tell you that, okay, fine, if you have any questions, you can ask now, or whatever questions you have, I'll keep giving you after maybe every small topic. I'll keep giving you some time to ask your questions, to ask your doubts, and this is when I'll also look at the chat and I'll answer each and every one of you and every question that you have with regard to this session, right? So let's begin. So first, to look into the basic understanding of science and technology, we need to know first about what do we mean by science and tech, right? We first need to understand what is science and technology and what is the syllabus. And for any subject that you start with, any subject, the very first requirement is to understand the syllabus of that subject, so that you know what you have to read, you understand what you need to do, and accordingly you are making up your plans. Otherwise, there are a lot of chances that you just get lost in so much of material and so much of articles and so many of study material that is available to you, that you get lost in it and you forget about the importance of some of the selective topics which are very, very crucial from the examination perspective. So that's where syllabus becomes very crucial. And here, when we look at the science and technology syllabus, you see that in the prelims examination, if you look at the syllabus, there's only one thing that they've written, and that's general science. That's it. So now, when we say general science, it's very, very difficult to even say what general science could be. That how general is this general science, correct? Because everything that you have around you, in one way or the other, there is some application of science in it. So it's not very easy to just say that, okay, fine, this is what general science is, and this is what you have to read, and this is exactly from where the questions would come. So that's why this does not give us anything. One thing that I've added from my side is current events of national and international importance. Because when you look back into the previous year papers, and especially the science and technology segment, whether your prelims or your mains examination, you'll find that a lot of questions, a good proportion of the questions that come in your prelims or mains from science and technology, you'll find that a lot of it is also related to current affairs. And that's why once in a while, for every topic, whatever is a significant news from current affairs perspective, we'll keep taking that as well as the session progresses. Now, when you come to the main syllabus, this is where at least there are some basic points that have been given. So for example, science and technology development and their applications and effects in everyday life. So important applications and important developments in the field of science and technology become important, and we'll keep taking the examples as we go on to our chapters. Achievement of Indians in science and technology, indigenization of technology, and developing new technology. So this is the second part. So achievement of Indians in science and technology, indigenization of technology, and developing new technology. Now, new technology, of course, is one segment from where a lot of questions do come, correct? And you'll find that they'll keep asking you questions based on the new developments or new scientific developments that we see in the world. But apart from that, there is another thing mentioned. This is indigenization of technology. Now, when we say indigenization, the meaning is how do we use a certain technology in the context of our own country. So, for example, let's say a lot of technology that we are using, it's not that all the technology was developed in India only, and everything that we are using is completely homegrown and there's nothing that has been developed outside India. That's not correct, right? a lot of technology, or maybe let's say majority of the technology that we're using here, we know that it has been developed somewhere in the world, and then we have also adopted it, and then perhaps we have localized it, we have changed it, modified it according to the requirements of this country. That, in a manner, you can say is indigenization of technology. And especially when it comes to the space sector, defense sector, communication sector, these are sectors where indigenization becomes very crucial, because then only you are able to cater to the needs of this nation. And then the other part is achievement of Indians in science and technology. Now, when we say achievement of Indians, it's not about that you have to read about a scientist or the biography of a scientist. Not required, because that's history. If at all they had to ask biography of somebody, they would ask you in GS paper 1, why in GS paper 3. So when we say achievement of Indians, we basically mean the achievement of various sectors, whether the energy sector, whether the space sector, biotechnology, nanotechnology, communication sector, whatever the sector be, defense sector, anything. So when we say achievement of Indians, we mean what India has achieved and not what an individual has achieved. Correct? So just understand this. And then lastly, when we look at the last part of what's given in your syllabus, and this is where it becomes very, very crucial, awareness in the field of IT, space, computers, robotics, nanotechnology, biotechnology, and issues related to intellectual property rights. So these are the things that you have to actually study. Whether for your prelims or your mains, you'll find that these are the topics which are related to each and everything else that we have seen here. Whether the general science of those topics, whether the developments and applications in these topics, or the new developments in these topics, but these topics will form the crux of everything that we need to discuss. So when you look at the topic breakup and every topic that we have to read, these are the topics. So energy and space. Now these two topics, the first two topics, these are for from my understanding and my experience. I would say that these are the two most important topics from where the questions keep coming every year, and we would expect the most number of questions, whether in prelims or in mains, to come from these two chapters. So that's why they are crucial from the perspective of both your prelims and your mains examination. And the total study matter that we have in these two chapters is also the most. Perhaps our first entire week will go in just understanding the various aspects of only these two topics. And then after that, we will start going to the other topics. And these other topics, they are not going to be as big as a chapter as the first two topics are going to be. So that's why energy and space, these two chapters are going to take a lot of time and a lot of patience from you, so that we can keep on completing all these topics. Then we have biotechnology. Now, biotechnology also, from the perspective of the examination, I'll definitely say that it's important for both prelims and mains. But as a chapter, it's not as big a chapter as the first two chapters are. So biotechnology as a chapter will be smaller, but still very relevant, still very important from again both prelims and mains perspective. Then nanotechnology. Nanotechnology, I would say that primarily it is important for your prelims examination. But now see, when I say primarily important for prelims, it doesn't mean that in the mains examination they can't ask you a question from here. They can, they have asked questions from here. But the way the chapter is built, chances are higher that a prelims question comes rather than a mains question. Then same goes for actually robotics and artificial intelligence also. That chances are higher that a question would come in your prelims rather than mains. But again, you cannot say that questions will not come in mains. 2023 mains paper, there is a question on artificial intelligence. IT and communication, the same thing. That primarily important for prelims examination. Intellectual property rights is a topic which is more oriented towards your mains. But again, as I said before, questions can come in your prelims as well. Now, the other two chapters, diseases and defense, although not mentioned in your syllabus, correct? We just saw the syllabus of your prelims and mains exams. There's no mention of diseases or there's no mention of defense, but questions do come from here. And one thing that you'll notice that whenever questions come from these two topics, they often come in the context of your current affairs. So So that's why the way you have to read, the way you have to understand these chapters are largely going to be oriented towards current affairs. And you do not have to think about the static knowledge in these two areas, because you go back and look at all the questions that have come from these two chapters. You will find that 9 out of 10 questions that they have asked, it has come from something that was in the news, and they have asked it only because it was in the news. So that's why these two chapters specifically, I would say that these are largely oriented towards your current affairs, and current affairs is going to play a very, very important role in these two chapters. Now, coming to the basic understanding of the past trends, although past trends in an examination like civil services is of no use, because you cannot bend your mind thinking about, okay, fine, okay, look at this area and so many questions being asked from this area. Oh, or look at this area, there's no question being asked from here. So maybe next year also they're not going to ask a question. So unfortunately, the civil services exam doesn't work in that way, that it's not that if this year questions have come, next year questions will not come, or if this year questions have not come, next year they'll ask more questions, or maybe because last 3 years there is no question from this topic, so this year also perhaps they'll not ask you a question from this topic. Unfortunately, this is Union Public Service Commission, or in other words, Unpredictable Service Commission, some Public Service Commission, or UPSC. So that's why, don't think about the pattern, but yet you should know about the pattern. So for example, when we look at science and technology prelims, we see that a maximum of 16 to a minimum of 12 questions have been directly coming from this area, right, every year in prelims. So this is the range, 12 to 16. Sometimes maybe less, sometimes maybe more. Chances are that maybe they'll ask you just 5 questions from here next year, or chances are they can ask you 20 questions from here, and you cannot hold them accountable for that, saying that I had seen the past trends. You have never asked so many questions or so less number of questions. Why are you doing it now? So you can't do that, right? You cannot do that. So that's why trend analysis is good for you to know that, okay, fine, these many questions come, but it doesn't predict what will happen next year. Just remember this. And then from the mains perspective, we see that every year 3 to 4 questions they would be asking. So the range, you can say the range would lie between 35 to 50 marks, 35 to 50 marks in your mains examination. Now, when I look at the questions asked in prelims and versus questions asked in the mains, you'll find that questions asked in the mains examination are actually easier as compared to the questions that have been asked in the prelims examination. This is something that we see in general science and technology. And when I discuss and when we go to the chapters, I'll keep taking a lot of examples, and I'll show you how the questions in the past have been asked. So you'll understand that questions a lot of times in the prelims examination are more difficult in science and technology, and the mains examination rather, the questions are easier in their nature. So that's why this is very crucial for us to understand that how the mains examination will be easier for you, and questions will be fairly easy as compared to your prelims. And then lastly, coming to the sources that we are going to refer to, or what you should refer to for science and technology. Look, when we look at science and technology as a subject, what you would see is that this is a very different subject as compared to many of the other subjects that you're learning, and there is no role of any standard book as such, because in some of the other subjects you have a standard book and you can base your preparation on that standard book, but that doesn't work in science and technology. The kinds of questions, the pattern of questions, they do not align with any of the standard books as such. So I wouldn't suggest that you go through any book. Now, what the sources are: first, newspapers become very crucial sources, especially two newspapers, the Hindu and the Indian Express. These two newspapers, or at least one of them, would be very, very crucial for science and technology preparation. Then the second can be PIB, or Press Information Bureau. Now, Press Information Bureau is important because all the official information from the side of the government is what you get in PIB. So what different ministries are doing, what their policies are, what their schemes are, what are the new initiatives that they're taking. So every new thing or anything of importance from Indian perspective will be all published in the PIB. So that's why PIB, or Press Information Bureau, becomes a very crucial source. And you have the website also, that is pib.gov.in. If you want, you can go to this website also, and very cleanly, ministry wise, date wise, you will see the arrangement of all the important news. Then after that, there are magazines: Science Reporter, Down to Earth, Yojana, Kurukshetra magazines. Now look, when it comes to all these magazines, I again wouldn't suggest that you go from cover to cover and read each and everything in these magazines. There are only selected few topics which are going to be important from these magazines, and we'll keep covering those topics in our webinars, for example. So in the webinars, I'll keep taking, whenever I take a science and technology webinar, I'll keep taking the important topics from all these areas, and they will very all the crucial topics I'll keep taking, because otherwise reading these sometimes can be very tricky, especially a magazine like Science Reporter can be too technical at times for you to read and comprehend and understand. So that's why it's better to be selective, and we'll do that job for you. Whenever we do our webinars, we'll keep doing your this job for you. Now, lastly, the role of NCRTs in science. Now, when it comes to NCRTs, my suggestion always is that somebody should definitely read class 6 to 8th NCRTs. Class 6 to 8th NCRTs of general science. And even in class 9th and 10th, even in class 9th and 10th, see, there are certain chapters, if at all you want, there are certain chapters that you can study. For example, there's a chapter, structure of atom. So this is a chapter that can be studied. Then there is a chapter on gravitation. So gravitation could be a chapter that you can study. Then there is a chapter called as fundamental unit of life, which is basically based on our cellular structure. So fundamental unit of life. And then there are a couple of chapters based on the human body, the various aspects of the human body, for example, digestive system, respiratory system, and so on. So those things can be studied. So even reading from class 9th and 10th, I would still say that you should be selective and not just try to read each and everything. When it comes to class 11th and 12th NCRTs, my strong suggestion would be stay away. You do not need to read class 11th and 12th NCRTs. They are too technical for you to understand, and especially if you do not come from science background. If you have not taken science in class 11th and 12th, then in that case, it's almost impossible to understand what's there in class 11th and 12th NCRTs, and that too to cover it in a month's time. For those of you who come from science background, you know this, that covering class 11th and 12th science books would perhaps need a year's time, or let's say at least 6 to 7 months of time to complete those chapters. So that's impossible for somebody to even think that you'll be able to complete anything. And secondly, questions wouldn't come from here. They become too technical to be asked in a UPSC examination. So that's why stay away from class 11th and 12th NCRT books of science, meaning physics, chemistry, and biology books. You should not touch. That would be my suggestion, my humble suggestion. But just understand this. Now, overall, when it comes to all this, so this is a basic structure of what you have to study before moving on to the first chapter, that is energy. Energy chapter will start with, but before going there, if you have any questions from whatever we have discussed until now, you can ask me, and then after that, we'll move on to the first chapter. So if you have any questions, please let me know now. Not able to communicate with anyone from Byju's team. If at all there is any issue that you are facing, please send the problem to me at rashesh.kumar@byju's.com. If any team needs to be spoken to, or if let's say there is any problem, I'll forward your doubts to them. Webinars, the science webinar, one part, because I was also not able to. So there is one part that is, I think, going to be available today, because I've sent, there were some issues with the way the session had to be done. I had to show certain videos, etc. So in the live class, that was not possible. So I've given the recording of the science webinar of April to the team, and I think it is going to be uploaded tonight. Polity classes, I'm not sure, because I was told that I have my classes from today onwards. Maybe after me, polity classes would begin. Does conceptual questions come in science and technology in prelims? Yes, actually, most of the questions will be conceptual in nature, and this is how science and technology is supposed to be asked. So factual questions will more or less will not be there. Do we have to prepare notes? See, I'll keep writing also. There is a lot already written on the PPTs, and all the extra information that is required apart from whatever is already there in the PPTs. I'll keep writing that down, so you can keep listening to the class and just go along with it and collect the annotated uh, PDF later on. But if you are somebody who has a habit that you keep writing along with the classes, please do that. So it's completely uh, your choice. But if you don't want to, everything will be there on these PPTs. Is it compulsory to read NCRTs? I would say that class 6th to 8th NCRTs everybody should read. Beyond that, it's optional if you have time. Otherwise, class 6th to 8th NCRTs for sure everybody should read. No extra book is required, nothing else is required. Just understand that these class 6 to 8 NCRTs for your basics is enough, and apart from that, only everything that we are doing in the classes, that's it, plus the current affairs. So the current affairs that we are giving you, plus the classes that I'm conducting. Beyond that, you do not need anything in this subject. Please do not read any book. Please do not waste your time in reading any book. That is not required beyond these NCRTs that I just suggested you. That's it. I have attended your recorded lectures in the tablet. Is there need to make notes? See, the recorded lectures are a bit older, so that's why some of the current affairs and some of the recent changes that have happened, they may be missed there. So I would still suggest that even if you have done that, you still attend these sessions, because they might be 60 to 70% same, but the rest 30% probably will be different. Can you write the notes instead of slides? I don't understand this. I'll keep writing. That's why I said that I'll keep writing wherever necessary. For Yojana Kurukshetra, should we refer mandatorily or current affairs is enough? See, Yojana Kurukshetra also you have to be very selective, because every month Yojana Kurukshetra magazines will drop and there will be 3 4 articles which will be important. You also should look at who has written that article, because importance of article will also be decided on the basis of who has written it. So that's why these things should be considered, and that's why you have to be very selective while reading it. Vinay Sinha, you have asked, is it compulsory to read NCRTs or just follow the class? See, again, just I'm repeating that class 6 to 8 NCRTs, I would still say is important. Whether you come from science background, you come from non-science background, doesn't matter, because it would have been a long time since you did not study all those topics. So it's very easy to forget everything, although easy, but you still might not remember. So I just want you to go through those chapters of science and science from class 6, 7th, and 8th. Will there be questions based on calculations? No, they have stopped doing that. It used to come until 2008, 2009. You will see that there are some numerical problems, but since the change in syllabus happened in 2011, since then they have never asked any calculation based question, and it's unlikely in the future that that would happen. Did you cover environment? No, environment I think has been taken by Basavaraj sir, if I'm not wrong. All the chapters of class 2 8th, more or less. There are some chapters which are more geographical in nature, like land, water, air, etc. Apart from that, everything you can read. Reading one newspaper is taking more time. In this case, how to manage time? See, newspaper reading should always be done with the newspaper analysis that we do, for example, because we would have already selected those articles, we would have already made the notes in it, we would have already given you the explanation. So after that, covering those topics become very easy. So even if you are reading the newspaper, do it along with the news analysis that we do. So, and I'm not saying that you should go through two newspapers. What did I say? Any one of these two newspapers, just follow any one of these two newspapers, and that's enough. If we ignore the recorded lectures and only attend these live classes, will it be enough? Of course, it will be. I will give the exam in 2027. Now, am I focusing on current affairs? No, then current affairs for now you should not study current affairs for now, because current affairs for anyone who's preparing would be important for maximum of last 15 months. That's it. Maximum of last 15 months, not beyond that in any way. So for now, you should just focus. Anyone who is preparing for beyond 2025, for now, you should only focus on the basics and covering the syllabus, and don't bother about current affairs now. Any website that we need to follow, I wouldn't say you need to, because anything that is required, I'll keep doing it in the class itself. Need to make NCRT notes separately? Again, no. Just underline the basic points in the book itself. That should be enough for you. And that too, you do not need to buy the books. You can go to NCRT website, and there you will find the PDFs of all the books also available. So it's not that you need to necessarily buy the book. You can even download it and you can read from there. Kirti, to answer your question, we are doing everything possible to ensure the answer to your question. Are the diagrams important? See, there are some areas where it will be important, and we'll discuss about that whenever those kind of areas come up. Huh. Can I attend webinar because I'm giving my first attempt in 2027? Again, not required for now. You can go through it just to listen, just to be aware, but not in a manner that a 2024 or a 2025 candidate would have to. Will it be enough to watch and understand the news analysis instead of reading newspaper? See, if you have time, that I then I would say it should always be a point that you make a habit of reading the newspaper, because that is where you start to make some effort. Until the time I am giving you the newspaper analysis, I am the one making all the efforts and you are just listening. But when you also read, then this is where your brain starts to make efforts. Now it depends on time, that let's say you are somebody who's working and you have very limited time in your hand. So in that sense, it's okay to just go through the newspaper analysis and just watch the lectures that we do every day in the morning. But if at all you have that time, that you can give extra half an hour to 45 minutes to also read those articles that we discuss in the news analysis, then do that. Syllabus slide, this is the syllabus slide. All right, so let's move ahead. Yeah, everybody in 2024 and 25, you should be very thorough with your current affairs even now. Right, so let's begin with our first chapter, and this is the chapter of energy. Now, energy as a chapter, as I told you, that it's a chapter which is important for both your prelims as well as for your mains examination. And we do expect questions to come from here in your prelims and your mains examination. Now, when we say energy, what is the meaning of energy? In simple terms, what we say is that energy is the capacity to do work, right? We say that energy is the capacity to do work. So for anything that you do, you need energy. If I have to take this lecture, I need to have eaten some food so that I can deliver this lecture. You also, to sit for 3 hours and not be bothered, your stomach should be, uh, you can say, at least half full, so that you are able to sit through the lecture and your stomach doesn't start telling you that okay, fine, you can watch the recorded lectures, but please eat your food first. So that's why energy is the capacity to do work for anything that needs to be done. It's not only about you and me, it's about everything that happens in this entire universe. For anything to happen, energy is required. There must be some form of energy that is there behind any kind of work that is happening in this universe. Now, energy is basically measured in joules or calories, as we mentioned it, and it exists in a lot of different forms. Now, here we are not going to talk about the physics of energy, but this chapter rather will be about the various sources of energy. That first and foremost, how do we classify energy? What is energy according to definition? So, when we think of classifying energy, there are two basic ways in which we classify energy. One on the basis of renewable and non-renewable energy, and second on the basis of conventional and non-conventional sources of energy. So first, let's try to understand what do we mean by renewable and non-renewable sources of energy. Now, suppose that I have any source of energy that I can renew, meaning that I have enough of it and it will not be wasted. And it's not that once it is consumed, I will not have more of it. So, if I have that kind of an energy, I would say that it is renewable energy. And by definition, one of the best ways to define what renewable energy is, you can say that any energy source where the replacement rate is better than the consumption rate, right? Replacement rate is better than the consumption rate. In that sense, we'll say that it is renewable, meaning that you are able to replace it much quicker. You are able to replace it, and you have enough of it that you will never be able to consume it completely. So that's a solar energy, wind energy. These are sources of energy that will be here forever. We have enough of solar energy to run this entire solar system. So forget about just our basic requirements. So when you have these kind of energy sources, and we know that these are energy sources that will exist as long as the earth exists, correct? So they are not just going to go away. So these kind of energy sources will be called as renewable energy sources. So that's why solar energy, wind energy, geothermal energy, biofuels, etc. They all can be called as renewable energy, because here the replacement rate is better than the consumption rate. You consume it slower, you replace it faster. This is the meaning. And then on the other hand, you have non-renewable sources of energy, where of course the replacement rate, or you can say consumption rate, is better than the replacement rate. That you consume faster, you replace slower. So for example, coal. We know that we started using coal at a very large scale since the industrial revolution, correct? Industrial revolution onwards, we have seen that uh, we have been using coal in a very extensive way for electricity generation, in iron and steel industry, in various different industries. We have seen that we have been using coal and petrol, coal, petroleum, natural gas, etc. So coal we started using, you can say, since industrial revolution, maybe 300 years back. But do you know how much time it takes for coal to form? The formation of coal, do you know how much time does it take? Formation of coal can take up to 300 million years. 300 million years. Up to 350 million years it can take just for formation of coal to happen. And we are saying that we used up coal just in 300 years. So just imagine, for India, it is estimated that we have almost 100 and 130 to 140 years of coal left. That's it. So something that took millions of years to form takes just hundreds of years to completely consume. That is what non-renewable energy is, where your consumption rate is faster than your replacement rate. So that's why coal, petroleum, natural gas, they are all called as non-renewable sources of energy. Now, in this context, there is another energy source that we are going to discuss in this chapter, and that is nuclear energy. Now, if I ask you, as per whatever logic that you can think of, is nuclear energy a renewable source of energy or a non-renewable source of energy? Please answer in comments. Is it renewable energy or is it non-renewable source of energy? Yeah, so I see a lot of renewable, a lot of non-renewable, and some correct answers as well, where it's very difficult to see. We'll discuss this in detail when we go to the part of nuclear energy in this chapter. But let me just make something clear, that it's very difficult to define nuclear energy as renewable or as non-renewable. It depends on factors. It depends on what is the logic that you apply, and that's why renewable energy can be both. It can be renewable according to some you can say some arguments, and it can be non-renewable according to some of the other arguments. So that's why it can be renewable, it can be non-renewable. It depends on how you see nuclear energy, and we'll discuss this in detail when I go to the portion related to nuclear energy. So that's why it can be classified as renewable as well as non-renewable based on certain factors, right? So based on certain factors, it can be classified as renewable or it can be classified as non-renewable. Now, in this particular scenario, when it comes to classification of energy, another way in which we can classify energy is on the basis of conventional and non-conventional sources. Now, conventional sources are the ones that these are the sources that we have been using for a long time, that we have known about the uses for a very long time. So then we'll say that these are conventional. So coal, petroleum, natural gas, firewood, straw, dried dung, etc. All these they have been in the use in domestic ways and industrial ways as well, and we have known about them, their existence for a very long time. On the other hand, we have non-conventional sources where we have developed our understanding only maybe in the last few decades. Solar energy, wind energy, biofuels, all these basically are energy sources which are non-conventional because we haven't been using it for a very long time. We understood how to use it, and maybe past few decades we started using these sources of energy. So that's why conventional and non-conventional. Now, what you will find is that usually the conventional sources are the ones which are non-renewable, and the non-conventional sources are the ones which are renewable in nature. But is it a rule? Is it a hard fact? The answer is no. It's not necessary that all the conventional sources will be non-renewable in nature and all the non-conventional sources will be renewable in nature. It's not necessary. All right, it's not necessary. So that's why there are sources, and we'll discuss about these sources as well. There are sources which are non-renewable and non-conventional both at the same time. We'll discuss about shale gas. We'll discuss about coal bed methane. So all these, or even methane hydrates. We'll discuss about all these also, and you'll find that in these cases, they are non-renewable and non-conventional both at the same time. So that's why it's not a hard and fast rule. It's not a rule that always conventional will be non-renewable and all the non-conventionals will be renewable in nature. It's not necessary. All right. So this is how we classify energy. So now what we'll do is that we'll start going to each and every portion that we have to study. And while we do that, while we go on to study each and every portion, first we'll start with the non-renewable portion. We'll discuss coal, petroleum, natural gas, etc. first. Then we'll go to the renewable sources where we'll discuss about solar energy, wind energy, biofuels, etc. And then the last part of our discussion will be about nuclear energy. So this is how the chapter division will be. So today we'll be focusing more on the non-renewable energy, and we'll start with probably the renewable energy part. Tomorrow we'll be largely dealing with the renewable energy portion, and maybe day after tomorrow we will start with the nuclear energy portion. So these 3 days, perhaps this is how we'll be conducting the sessions. So first we start with the non-renewable sources where we have coal as our first source. Now when we look at coal, we say that coal is a fossil fuel. Coal is a fossil fuel and altered remains of prehistoric vegetation. Altered remains of prehistoric vegetation that originally accumulated in swamps. So when it comes to the formation of coal, all right, when it comes to the formation of coal would have begun on land, in marshy areas, in wetlands, in these kind of areas, where the vegetation that existed in these areas due to some reasons, maybe seismic reasons, maybe geological reasons, but because of some reasons, these vegetation that were growing in the marshy areas, in swamps, in wetlands, they got submerged under land. All right, they got submerged under land, and while getting submerged, they also mixed with the sediments, and as they go down, the temperature increases, the pressure exerted on them increases, and under these conditions of high temperature and high pressure, they start converting. So from vegetation, they now convert. They convert into what? They convert into coal. So this is how the formation of coal would have happened. That coal formation would have begun 360 million to 290 million years ago. And the buildup of silt and other sediments, together with the tectonic movements, they buried the swamps and the peat bogs often to very great depths. And with burial, the plant material was subjected to high temperature and high pressure, and this caused physical and chemical changes in the vegetation, transforming it into coal. All right. So this is basically what we know about coal formation. That in the wetland areas, the marshy areas, the vegetation got submerged under land, was subjected to high temperature and pressure, and hence converted into coal. So this is how formation of coal would have happened. Now, depending on how much time, how much pressure, and how much temperature, we see that there are various different variants of coal. There are different variants of coal, and that these variants, they depend on for how much time, how much pressure was exerted, and what kind of heat it was subjected to, how high temperature was it subjected to. And depending on that, we see various different types of coal. So when you have, for short period of time, low temperature or lower temperature, lower pressure, it got converted into peat, which is an organic form where complete conversion into coal did not happen, because it was not subjected to high enough temperature and pressure for good enough duration of time. So depending on how much duration, depending on how much heat it was subjected to, depending on how much pressure was exerted, the quality of coal is decided. The best quality of coal is the one where the pressure and heat was the highest, and for longest duration of time it was subjected to high temperature and pressure. So that's why quality of coal is dependent on this. So I'll just write it here. Quality of coal depends on time, pressure, and temperature. The higher these factors, the better the quality of coal. All right. So this is how quality of coal is decided, and these are the four types. So as you can see, when you look at peat, peat doesn't look like coal. That when I say coal, the image that is there in your mind is of something like a bituminous or an anthracite. Correct? You do not think of coal like a bark of a tree, and peat looks like bark of a tree because complete conversion did not happen. It is the lowest grade coal, it is the lowest quality of coal because complete conversion into coal did not happen in terms of in the case of peat. So it was subjected to lower temperature, it was not subjected to very high pressure, and not for a long duration of time, and that's why complete conversion into coal did not happen, and it remained like this. So that's why it is the lowest grade coal, it is the lowest quality of coal. And then after that we have lignite, and lignite, as you can see, is in is brownish in color. So that's why many a times it is also called as brown coal. We also call it as brown coal. So why we call it as brown coal is largely because of the brownish appearance that it has. Now again, not a very good quality coal, but of course better than peat, but not as good as bituminous or anthracite. Now when it comes to lignite, there is one important property of lignite, that it is possible that it might undergo spontaneous combustion. So it might undergo spontaneous combustion. What do we mean by spontaneous combustion? That it can catch fire on its own. It can catch fire on its own when it gets any, you can say, condition which is favorable for its burning. So what happens is, let's say in a lot of coal mines, they are at very high temperature and pressure. Now when mining happens, or in any way, maybe due to natural processes, maybe due to a natural disaster, right? If at all Many times what would happen is that they are already at high temperature and high pressure. It is a fuel. If oxygen is able to reach this coal, sometimes it is possible that it creates a favorable condition for the combustion of lignite. So many a times when coal catches fire or there are fire accidents, and thankfully now we have better technology altogether, and we do not see these kind of accidents. But you look back into 1950s and 1960s and go back to the newspapers, maybe do a basic internet search, you'll find that there were a lot of fire accidents inside the coal mines that used to happen in India and in China. China has one of the largest deposits of lignite in the world. So in China also it used to be a big problem, and in India also, even post independence, you see that it used to be a big problem, and there are a lot of lives that we have lost because of these kind of incidences. So that's why it has a property that it can undergo spontaneous combustion. So about lignite, this is something which is important to know. Then coming to bituminous. Bituminous basically is also called as, sometimes we call it as industrial coal. It is also called as industrial coal. Now, when it comes to industrial coal, why industrial coal? Because you'll find that in most of the cases, wherever we are making the use of coal, bituminous is the most preferred form of coal in industries, in electricity production, etc. Everywhere, bituminous is what is the most sought after. And then lastly, we have anthracite. Now, in case of anthracite, what we basically see is that anthracite is the best variant of coal, is the highest quality of coal. Uh, and that's why it has very nice, very good efficiency. It burns very clean. All these are some of the properties that anthracite has. So that's why when you look at a comparison of uh, all these different types of coal, if you look at the carbon content, the lowest carbon content, of course, is in peat, and it is generally less than 40%. It is less than 40%. For lignite, usually it is 40 to 55%. For bituminous, it is generally 55 to 80%. And for anthracite, it is 80 to up to 95% of only carbon. And that's why the efficiency is also the best when it comes to anthracite as compared to peat, which has the lowest. Then ash and volatile matter content, of course, is the highest in peat because carbon content is low, so the impurities are high. So it has higher impurities. In case of lignite, little lower, bituminous low, anthracite very low. Now, when it comes to where they are found, if you look at these maps represent where exactly do we find coal. So these three states, if most importantly, Jharkhand, then Odisha, and then Chhattisgarh. These are the three states in India which have the highest quantity of coal. Right, the most amount of coal that we have in India are concentrated in these three states. So that's why these three are the most important coal states in India. But it's not that it's limited only to these three states. As you can see in the other map here, what you basically see is that all these areas are where we find coal. So Jharkhand, Odisha, Chhattisgarh, Maharashtra, Telangana, Andhra Pradesh, West Bengal, even parts of Uttar Pradesh and Bihar. Sorry. So this is the central region where we find coal, and largely the coal that is found in this area is bituminous. Now remember, when I'm saying that largely bituminous, it does not mean that it only has bituminous. It does have other variants of coal also. You will find peat also here. You will find lignite also here. So you will find other variants of coal also. But the amount of bituminous that we have in this part is the highest in the country. So Then after that, when you look at the northeast, in the northeast, especially in Assam, Meghalaya, and Arunachal Pradesh, even in Sikkim, we find that peat is found in large quantities. All right, peat is found in large quantities. Then in these areas of Rajasthan, Gujarat, Tamil Nadu, in Puducherry, these are Indian areas of lignite. Even in Kerala, these are areas of lignite. And this part here in Jammu and Kashmir, this is the portion where anthracite is present. All right. So this is where we have anthracite. But unfortunately for India, we do not really have a lot of anthracite. We have very limited quantity of anthracite. So that's why when we need higher grade coal, we actually import coal. We import coal from a lot of different countries. So that is basically how we see the distribution altogether. So coming to the uses, what we see is that peat largely will be used in agriculture, in water filtration, as a domestic fuel. So these are the ways in which we make the use of peat. Now, uh, in the industries, of course, we do not use it because first it pollutes a lot, and second, its efficiency is very, very low. So, because of these two reasons, we do not really prefer it at all when it comes to energy sector or different various areas where we can make the use of peat. So, in agriculture, it is. For example, even if you go to an e-commerce website and you type peat, you will get the results for peat, because that is something that can be used in gardening as well, because it is organic in nature, so good for the growth of plants. So even if you go to an e-commerce website like an Amazon or a Flipkart, etc., you can actually find peat there as well. Then coming to lignite, lignite will be used in the industries. It is used in electricity generation as well, and we see that it is something that can be used as domestic fuel. But again, because the impurity levels are on the higher side, we prefer not to use it. And then after that, we have bituminous. Bituminous is also called as coking coal, used in the industries, used in uh, electricity largely. So coking coal is something that is used in electricity, and again as a domestic fuel. But it is the most important uh, kind of coal. And then lastly, we have anthracite, used in heating systems, smelting of fuel, etc. So in all these cases, anthracite can be useful. Now, when it comes to coal, one thing that is very, very necessary to understand is something called as coal ash. Now, coal ash is what? The remains. After the combustion of coal is done, the remains, the impurities in the burnt form, is what we call as coal ash. Now, there are different types of coal ash. This one that you see is called as fly ash. This is called as fly ash, and this kind of ash largely is called as bottom ash. All right, it is called as bottom ash. So fly ash and bottom ash. Now fly ash has been given this name fly ash because it can fly, because it is very lightweight. As you can see that it is like a powder, correct? It's in the powdered form. So that's why the name fly ash has been given to this kind of coal ash. On the other hand, when it comes to bottom ash is larger in its size. As you can see that it's larger in its size, and that's why it is something that will deposit at the bottom of the boiler or the furnace. So it's easier to remove. But when it comes to fly ash is very thin. It is just like dust. So it can very easily just go and escape from the chimneys of these power plants as well. And then they'll mix with air, they'll mix with nearby water bodies, with land. So making air unbreathable, making land uncultivable, and making water undrinkable. So that's why fly ash becomes a major challenge for us. So when it comes to coal ash, so we are talking about the combustion residuals, and this is where uh, we see that it is something that comes from the burning of coal in the coal-fired thermal power plant. Now, here we know that it's not only about the dust, or it's not only about the fine material that has been formed, but at the same time, it does contain lead, arsenic, mercury, cadmium, and even chances of uranium as well. So that's why we see that there are all these different types of heavy metals also that can be present in coal, or especially the coal ash. So fly ash, a powdery silica material created when fine coal, pulverized coal is burnt, or bottom ash is a more coarse material particle that forms at the bottom of a coal furnace as uh, it is too large to be pulled out through smokestacks. So in this manner, we see that there is fly ash and there is bottom ash. There are these two also. We have boiler slag and we have flue gas desulfurization material. So boiler slag, again, it's a type of bottom ash itself that is in a partially molted fused state, and that is basically what boiler slag is. And boiler slag has silicon dioxide, aluminium oxide, and iron oxide, and at the same time also calcium oxide. Has a very glassy appearance and is usually black or dark gray in color. So this is what boiler slag is sometimes seen. And then after that we have flue gas desulfurization material. So flue gas desulfurization material is used for removal of sulfur, correct? It is used for removal of sulfur dioxide that can be a wet sludge or a powdered material with azoted sulfate. So that's why it is something that is composed of calcium sulfate and dihydrate at the same time. It's calcium sulfate dihydrate, and this is what we also call as gypsum. So now when it comes to boiler slag or when it comes to flue gas desulfurization material, just remember that these two are not really found in large quantity, so they are not the threats for us. What is the threat? The threat is fly ash, because it is very very difficult to get rid of fly ash. For the very first thing, very very difficult to get rid of fly ash, and that's why fly ash is the biggest problem. Now in this particular scenario, that's why the disposal and recycling, especially of fly ash, is very important. So first, when it comes to disposing, the disposing of fly ash either can be done through landfills, that you dig up land, you fill it with fly ash and you cover it, or many a times abandoned mines are used. So either landfills will be used or abandoned mines are also used, where we just go and keep dumping all the fly ash. But at the same time, it can also be used as an additive. It can be used as an additive in cement, in grout, in concrete. So for example, these kind of bricks, the bricks that you see here on your board, so these bricks are also made of fly ash. These kind of bricks you might have seen here and there everywhere, wherever constructions are happening. Either the red colored brick or this kind of a brick. So this brick that you see right here on your screens, this is the brick which is made of fly ash or cement mixed with fly ash. And bottom ash can be used to stabilize a fill and control the snow on the roads. So in case of bottom ash, what happens is that it becomes easier for us to collect bottom ash, and then we see that it is actually used in removal of snow because it is a good absorber, so it absorbs the moisture from its nearby surroundings, and that's why it becomes useful in removal of or control of snow. Now after this we have a very very important topic, and this is a topic that I would say is crucial from your prelims and mains perspective, and this is coal gasification. Now what we mean by coal gasification is that we are converting coal into synthesis gas, something that we also call as syn gas, or something which is also called as synthetic gas also. Now primarily this syn gas is a mixture of carbon monoxide and hydrogen. Primarily a mixture of hydrogen and carbon monoxide plus small quantity small quantity of carbon dioxide also. All right, small quantity of carbon dioxide as well. So there are all these things that are present in syngas. And coal gasification is nothing but conversion of coal into this gas. How would we do that? By heating it. But by heating it, we are also using the same thing in a furnace or a boiler where coal is getting converted into heat, and that heat is being used for electricity generation. So how is that process different from this process? So in this process, what we see is that the temperature that we need to raise is way higher as compared to a thermal power plant. In a thermal power plant where coal is being used for electricity generation, you reach like 350, 400 degrees Celsius. In case of coal gasification, we reach a temperature of around 1200 to 1500 degrees Celsius. 12 to 1500 degrees Celsius. So that's why in this particular scenario, we have a gasifier, which is a high pressure vessel that heats the coal to a temperature of around 1200 to 1500 degrees Celsius in the presence of steam and oxygen. And this high temperature and pressure will cause the coal to break down into its basic chemical components. And this is where we see that we start getting carbon monoxide and hydrogen mixture, which is called as the syngas. So this is what coal gasification is, that you will be heating coal to a way higher temperature. So that's why gasifying coal, converting coal into gas, that's why coal gasification is the term that we are using. Now, coal gasification today for India has become very crucial. And especially in the last couple of years, you'll see that there have been a lot of discussions around coal gasification. For example, in this year's budget, coal gasification was mentioned again, although it was just an interim budget. But again, coal gasification is something that was mentioned, and cabinet has approved rupees 85 crores in incentive scheme for coal gasification project. Now, when it comes to coal gasification, why do we want coal gasification? Are there any advantages? Why do we want to spend so much on money on coal gasification? And it's not that the discussion has started for the first time. You look at the budget speeches of last 3 years, you'll see that coal gasification has been mentioned. You go to the annual reports of Ministry of Coal, you go to the annual reports of Coal India, you'll find that in all these cases, coal gasification has been mentioned. So coal gasification today becomes very, very crucial because we see that there are a lot of steps being taken to uh, ensure the success of coal gasification in India. Now, so that's a coal gasification, and understand why. That why are we so adamant on coal gasification? First, it gives you cleaner burning, that we are able to convert it into a gas, and that's why the use of this gas will lower the emissions of pollutants like even sulfur dioxide or nitrogen oxides or particulate matter, not only carbon dioxide. So we see that we get cleaner burning. Then it has a much better efficiency. That efficiency can be up to 95%. Now 95% is big, because when you look at a coal, uh, in general, when you look at coal efficiency, you'll find that the efficiency is just around 30-35%. So on one hand, we are talking about 30 to 35% efficiency, and on the other hand, coal gasification is giving us up to 95% efficiency, which is huge. Then after that, it is very versatile. It can be used in a large varieties of applications, including electricity generation or heating or production of chemicals, etc. In all these cases, we see that it becomes more versatile. And then the environmental impact is also lesser because we have cleaner burning, we have less emission of poisonous gases or less emission of greenhouse gases. So that's why it can reduce the environmental impact. And then lastly, it will also help us in ensuring the energy security, and this is where we want to move, right? If you uh, look at this article piece as well, the adoption of gasification technology can reduce India's reliance on imports of natural gas, methanol, ammonia, and other essential components. Now, India has a target that we want that 100 million metric tons of coal gasification has to be done by 2030. That by 2030, we want that we should have a total capacity of 100 million 100 million tons of coal gasification we should have done. So that's why it becomes very, very crucial from India's perspective, and that's why we are putting so many resources, so much of resources on coal gasification. So that's why there are all these advantages that we have. So please read this question. Please read this question. I am launching the poll also for you. Please mark the question, mark the answer once you have read the question. It's an easy question. Please mark your answers. Wonderful. So 70% of you have marked A, which is the correct answer. So the question says, with reference to fly ash produced by power plants using coal as fuel, which of the following statements is or are correct? First is, fly ash can be used in the production of bricks for building construction. We discussed it, that they can be mixed and it can be used in bricks. Fly ash can be used as a replacement for some of the Portland cement, correct? uh, Concrete cement contents of the concrete. This is also correct. We discussed that we mix it with the cement. Fly ash is made up of silicon dioxide and calcium oxide only, and does not contain any toxic element. The whole point of our discussion is toxicity. We discussed that there is mercury, arsenic, lead, uh, uranium. So all there are all these different types of heavy metals which are all poisonous in nature. So we cannot say that it does not contain any toxic elements. We wouldn't even be discussing this topic if there were no toxic elements. So yes, it does contain toxic element, and it is completely, of course, not made of silicon dioxide and calcium oxide, because it's a mixture of a lot of different elements. So just also remember that these kind of words, wherever you come across, we often also call them as extreme words. Only, any, every, all, none. If you get all these kind of words, just remember that these words are extreme words. And whenever you have extreme words in any one of the statements in your answer, in your option, chances are, or I would say it's very highly likely, that it's a wrong statement. It's a wrong statement. Absolute statements are mostly wrong. 9 out of 10 times they perhaps will be wrong. So that's why this is basically what we see in terms of fly ash. Now, if you have any doubts from everything that we have discussed until now, please ask your doubts first and then we shall move forward. So, a couple of you have written about mentorship issues. If you have any problems as such with anything, as I told you, just please drop an email to me. I will take it forward with the mentorship team. Do these ashes cause increase in aerosol particles? See, any kind of dust particle actually can lead to increase in dust particles and can become a part of the aerosols. But largely, when we say aerosols, it's more of the particles which are chemical in nature. So, if we are talking about, let's say, particles of sulfur dioxide or carbon dioxide or carbon monoxide or soot particles, etc., yes, they'll all contribute to aerosols. The charcoal which is used to make road is which kind of coal, or is it something different? It is more of tar that is used there. It's not really made of coal directly, but there are some mixtures of petroleum in that, and that we'll discuss a little later. Every type of coal we burn, we get both types of ash. See, largely fly ash you will get from everything. Bottom ash is more a function of bituminous coal, because when we burn it in a furnace, then only we get that bottom ash many a times. What is shale gas? We'll discuss that. Just wait for some time. My email ID I gave you already, but just please note it. It's rashesh.kumar at byjuice.com. Do we have to show the map where coal is found in the exam? Depends on what you get in the paper. If at all, let's say it talks about the distribution of coal, it's good if you can just draw a basic indicative diagram. Fly ash can cause cancer. See, dust particles can. So technically, yes. How many lectures of science and technology? 11 or 12 classes will have of science and tech. PPTs of the lecture will be uploaded on your Byju's exam prep app. In notes, what to write? See, essentially, even if you don't make notes, it's fine, because all the important points are already there in these slides, and whatever extra points are required, I keep writing them, so that we don't waste a lot of time in just giving you notes and dictating you notes. Can we Is information of coal important for paper? Yes, of course it is. Otherwise, I wouldn't teach you if it was not important. Can we get the recorded session of this class? Yes, you anyway get the recordings of the class. Don't worry. How in Jammu and Kashmir the anthracite is found? It is cold area. See, today it is cold, but we are saying that the formation process began 300 million years back. So it is not related to an area being cold or warm or anything like that. We have coal reserves in Russia, much colder than Jammu and Kashmir. So depends on whenever or wherever the systems and the conditions rather were conducive for coal formation, and it happened wherever the system, wherever the conditions were conducive. Why European coal more effective than Indian ones? Not necessarily. Depends on, again, depends on bituminous. For example, our bituminous, the Indian bituminous, is of somewhat lower quality. All right, somewhat lower quality compared to the ones that we import. So when we import, we ensure that we only import the ones which are of better quality. Similarly, there are so many countries that also import coal from India. So they do that because they either don't have coal or they have even lower variant of coal. So that depends on the carbon percentage. So if we, whatever we have, if we are getting something better, we import that. Live classes enough for exam? See, live classes plus current affairs. These two together enough. Is there a reason that central India has high impact of coal? See, it's also because of the fact that you know that when it comes to the central Indian regions, these are the oldest regions of the country, correct? The central plateau, the Deccan plateau, the Chota Nagpur plateau areas, these are the areas which are the oldest areas. The oldest rocks basically are found in these areas. So that is also the reason. And the formation, again, formation is when the tectonic shifts started happening and when these kind of submergences happened. So luckily these were the areas where these conditions were conducive for the coal formation, and yes, then the coal formation happened. Science and tech is a kind of learning type of subject. They are fact, no, it's not fact based. I mean, most of the things, if you understand well, you'll be able to answer them well. How peat is helpful in agriculture? It's mainly because of the fact that it is organic in nature. It has coal components and sorry, carbon components and those materials, and hence it also helps in improving the productivity of the soil. How much time is required for current affairs? Look, current affairs is something which is a continuous process, and it's not that current affairs is something that you can directly do in the month of May or directly do in the month of April. No, it is something which is a continuous process, and you have to keep giving it time. Every day 1 hour, 1.5 hours, sometimes maybe just 40 45 minutes would be enough, but it is a continuous process and you'll have to keep doing that. India is importing coal rather than exporting. The reason is that we need a lot of coal, and especially when it comes to our electricity demands, we need a lot of coal on a daily basis, and that is completely not taken care of by all the reserves that we have. Hence, we use our reserves plus we also import coal. Hmm. Right. So let's take a break here. It's 6:30. On the other side, when we come back, we'll start with petroleum. So it's almost 6:30. So let's be back by 6:40. Right. Can we be back by 6:40? Hmm. Welcome back, everyone. So we discussed about coal and some of the problems related to coal, largely about coal ash and then coal gasification. Now coming to petroleum, another form of non-renewable energy, another energy form or another fuel form which is extremely important for us. Correct? Petroleum products like petrol and diesel are running the economy all over the world. So that's why petroleum also becomes very, very significant. Now, in case of petroleum, also we know that it is also a fossil fuel. We say that petroleum also is a fossil fuel, just like coal, and it also has taken almost as much time as coal formation has taken. So, in case of petroleum formation, also it could have taken a total of 250 million years for the formation of petroleum. So coal and petroleum in that sense are pretty similar. Both of them extremely important for any given economy. Both of them are the most important sources of energy right now in the world. Both of them are fossil fuels. Both of them are extremely polluting in nature. So they have all these similarities, but they are very different. I mean, if I compare coal with petroleum on the basis of their chemistry, on the basis of what they are, you'll find that they are very different. Coal and petroleum, they are very different. So for example, if you think of composition, in terms of composition, so composition wise we know that coal is made of carbon. Correct? Coal is made of carbon. Now when it comes to petroleum, petroleum is made of hydrocarbons, and I'll tell you what hydrocarbons are. So as you can see, it's a complex mixture of hydrocarbons. So composition wise, one is carbon, one is hydrocarbon. Then another difference, their origin. So for coal, what we discussed is that the origin would have been swamps, correct? Swamps, wetlands, etc. In case of petroleum, the formation would have begun underwater. The formation began underwater, under the seas, under the oceans, under the lake beds, but underwater. Coal formation happened on land. So that's another difference. Then the source from where they were formed, that also is different. In case of coal, we discussed that it is vegetation, correct? Vegetation that was growing in the marshy areas, in the swamps. In case of petroleum, that's different, because in case of petroleum, it would have been algae and zooplanktons. Algae and zooplanktons. So that's why in this particular scenario, when it comes to the source, also it's different. So in a manner, you can say that coal is only plant based, whereas petroleum can be plant or animal based. So coal is veg, petroleum can be non-veg. So that's the difference between the two. So that also is one difference, and one more difference, if at all we have to write on the basis of their state. Coal is solid, correct? Coal is solid in its state. Petroleum, what is the state? Petroleum, what is the state? Can you tell me what is the state? Because I see a lot of confusion here in a lot of students. All the states. Yes, Ananya, you have given the correct answer. Faris, you have given the correct answer. So all the states, it can be solid, it can be liquid, it can be gaseous. Petroleum products can be solid, liquid, or gaseous. So, for example, your LPG, liquefied petroleum gas, it's made from propane and butane, which are gaseous forms of petroleum. Then your petrol, diesel, kerosene, etc., liquid forms of petroleum. And then naphthalene, bitumen, etc., they are semi-solid to solid forms of petroleum. So that's why petroleum can be anything. When you say liquid, the liquid form is crude oil. All right. The liquid form is crude oil. So the term is also often restricted to the liquid form, which is the crude oil. So just don't confuse. Any one of these petroleum products can be solid, liquid, or gaseous, but crude oil, which is a mixture of all the petroleum products, it is liquid in its state. That is where the difference is. So that's why petroleum can be solid, liquid, or gaseous, whereas coal is solid. So that's another difference. So that's why you can see that coal and petroleum are very different. Although their usability is very similar for us, there some of the parameters are very similar for us, but in their structure, in their origin, in their composition, they're very different. Now, in case of petroleum, we are saying that it's a complex mixture of hydrocarbons. So what do we mean by hydrocarbons? The meaning of hydrocarbon is that it has elements carbon and hydrogen only. So wherever you have elements or wherever you have any compound which has only carbon and only hydrogen, then in that case it is called as hydrocarbon. Right? That is when you will call it as hydrocarbon. So organic compounds composed of elements carbon and hydrogen only, they will be called as hydrocarbons. So in this case we are saying that it's a complex mixture of hydrocarbons. Now what do I mean by complex mixture? Why am I calling it as a complex mixture of hydrocarbon? Because there are various different types of hydrocarbons that are mixed in any petroleum product. For example, just remember that let's say when it comes to something like a petrol or diesel or kerosene, etc. So when it comes to petrol, diesel, kerosene, all these, do you have a defined chemical formula for it? Like water is H2O, carbon dioxide is CO2. Do you have a formula for petrol? Do you have a formula for diesel? What do you think? Yes or no? Yes, the answer is no. The answer is no. Why? It's a mixture. If you just go back to your school time in class 8, ninth, etc., you might have studied about compounds and mixtures. That compounds have a fixed ratio of elements and mixtures do not have a fixed ratio of elements. So water is H2O. It's a compound. It has a fixed ratio of elements. But when we say something is a mixture, then in that case you cannot say that it has a fixed ratio of different components or different elements. So in case of petroleum products like petrol or diesel, etc., we are saying that it's a complex mixture of hydrocarbons, meaning that there are various different types of hydrocarbons which are mixed together, and sometimes some of the ratios are here and there. So that is why complex mixture of hydrocarbons. Now the formation of petroleum is also pretty similar to the formation of coal. That first you had the algae and the zooplanktons, and they, because of seismic reasons, tectonic reasons, geological reasons, they got submerged underwater, under the sea beds or under the ocean beds. They got submerged, and again they mixed with the sediments, just like what we discussed in coal. And then after that they were subjected to high temperature and pressure, just like what we discussed in coal. So these are the things that happened. So petroleum, uh, zooplanktons, algae, etc., and they settle to the sea or lake bottoms, mixing with the sediments buried under anoxic conditions. What do we mean by anoxic conditions? Absence of oxygen. Absence of oxygen, right? So anoxic conditions. And then what happened is that they, as they were buried in the lower regions, this is where they uh, were subjected to intense heat and pressure, and this is where they start to change. There is a physical and chemical change that starts to happen in all this organic matter, and it changes into something called as kerogen. So first you have the organic matter. All right. First, you have the organic matter algae, in terms of algae or zooplanktons. Then they are subjected to high temperature and pressure, and they convert to kerogen. They convert into kerogen. So this kerogen basically is, you can say, like a sedimentary rock. It's just like a rock from where we are able to derive petroleum out of it. So first conversion into kerogen happened. All right. So it's you can say in a manner it's like a sedimentary rock sedimentary rocks forming petroleum. So this is where petroleum would have been formed from. It just like a rock. You can just go. I forgot. I should have brought the images of kerogen here. If you just do a basic internet search, uh, you will see that kerogen is just like a rock. So first conversion into kerogen happened, and then what we see is that there is further breakdown that happens, and this further breakdown with more heat into the liquid and gaseous hydrocarbons, a further breakdown happens called as catagenesis. So from here on, the next process is catagenesis. Now the question is, what is catagenesis? Catagenesis basically is the breakdown of long chains of carbon atoms into smaller chains. So what I basically mean is that in the organic form, plants, animals, even in humans, the carbon forms that we have, the fat tissues, or let's say the protein tissues, etc., they would have carbon units, and the carbon units that they have, the organic units that they have, there we have very long chains of carbon atoms, meaning that there will be one, let's say, molecule which has, let's say, 80 carbon atoms, 100 carbon atoms, so a very long chain of carbon atoms. Now in catagenesis, this starts to break down into 15s and 20s, 15 carbon atoms, 20 carbon atoms, 10 carbon atoms, and so on. This is called as catagenesis. All right, this is called as catagenesis. So with catagenesis, the long organic complex molecules, they start to break down into simpler molecules. So carbon atoms of 100, carbon molecules of 80, 100 carbon atoms, it breaks down into 30s and 20s and 10s, etc. This is what would happen. Now this is not the end. There is another process lastly, which is called as pyrolysis. So after catagenesis, pyrolysis takes place. So pyrolysis basically, you can say that it is a kind of thermochemical decomposition of any matter in the absence of oxygen. All right, in the absence of oxygen. So this is what happened last, that here we are talking about a thermochemical thermochemical decomposition of matter in the absence of oxygen. So thermochemical decomposition of matter in the absence of oxygen is called as pyrolysis. So pyrolysis takes place here. After catagenesis, the smaller molecules that you have, they are going thermochemical. Thermochemical means what? That at high temperature, chemical conversion is happening. Thermochemical. Therm is the term that you use for heat. So that's why thermochemical, meaning that it is happening at high temperature. So thermochemical decomposition of matter in the absence of oxygen, and this ultimately leads to the formation of petroleum. So this is how the formation of petroleum happens. So ultimately we see that petroleum will form from this organic matter. More or less it is same as coal formation. little more complex as compared to coal formation. So this is how formation happens. Now what you get as petroleum is crude oil, and this crude oil is a mixture of all the different types of petroleum products. So the same crude oil has petrol, diesel, kerosene, jet fuel, all these things, they are mixed together. So this is where we have to now get them separated. And the process that we use for separation of all these useful components of petroleum is called as fractional distillation. All right, so we use the process of fractional distillation, and with the help of fractional distillation we are able to get the various different important components of petroleum. So what is fractional distillation? Let's try to understand that first. First things, what do we mean by distillation? So if I ask you what is distillation, then we'll come to fractional distillation. What is distillation? Distillation is a process that we use to separate out liquids which mix well in each other. So it is used in separating miscible liquids, meaning that the liquids that can mix in each other, they can be they can be separated with the help of distillation. What do we do in distillation? Use We use using the difference in their boiling points. So suppose that you have two liquids. One is water that boils at 100 degrees Celsius, and you have another liquid which boils at 50 degrees Celsius. And they have mixed well in each other. It's not like oil and water, where oil just forms a layer on water, which you can separate very easily. But let's say you have two liquids which can very easily mix in each other. Then in that case, you cannot simply separate them. So, and one of the ways in which we can separate them is distillation, where you start heating them. So as you heat this mixture, and when the mixture goes beyond 50 degrees Celsius, one of these two liquids will start to evaporate, correct? It will start converting into its gaseous state, and that can be collected elsewhere. So in this way, let's say by the time you are at 70 degrees Celsius, water has just started heating up while the other liquid has completely vanished. It has completely converted into its gaseous state. So distillation is a process that you can use to separate two liquids that can mix very well in each other. So, so for example, a simple example is mixing of, I've heard this from my friends, you will also hear this from your hands friends, that alcohol and water can mix very easily in one another, and there are people who are fond of it. Don't be fond of it, I am not fond of it, I don't want anyone to be fond of it, but those friends will tell you that alcohol and water can mix very easily in each other. So if you have to separate this alcohol from water, distillation is one of the ways in which you can do that. So distillation will be used in these kind of areas. Now comes, what is fractional distillation, right? So the next question is, what is fractional distillation? Now in terms of fractional distillation, the the basic concept is the same, that we are trying to separate out things which have completely mixed in each other, but this time the difference in their boiling point is very low. A normal distillation process can be used when you have a significant difference in the boiling points, 25 degrees Celsius or beyond. Largely speaking, 25 degrees Celsius or beyond, if that's the difference in the boiling points, we can use distillation. But if the difference is lower, 20 degrees Celsius, 15 degrees Celsius, 10 degrees Celsius, then using direct distillation is very difficult. So fractional distillation will be used separating mixture components with small difference, that is less than 25 degrees Celsius, in their boiling points. So what we do in the case of fractional distillation is that we will first take the entire mixture and we'll heat it to a very high temperature. All right, we'll heat it to a very high temperature and then we slowly cool it down. So the mixture is heated to a temperature higher than the boiling points of all the components and then slowly cooled down. Right, so this is basically what happens in fractional distillation, that you have this crude oil and this crude oil will be first heated to a temperature which is very high. It will be approximately more than 400 degrees Celsius, and then we start to cool it down slowly, so where you get bitumen, lubricating oil, fuel oil, diesel, paraffin, naphtha, petrol, and lastly you get butane and propane, which form the liquefied petroleum gas. So in this manner we see that this is how we keep on decreasing the temperature first, but we heat it to a very high temperature. This is what fractional distillation is. So this is what fractional distillation is, and something that we make the use of in terms of uh, petroleum, or getting all the important fractions of petroleum. So method of separating mixture of two or more liquids, and the process by which oil refineries separate crude oil into different more useful hydrocarbon products. So the mixture is first heated at a certain temperature from where fractions of the mixture will start to vaporize. So slowly and steadily we keep getting them. So that's why this process of fractional distillation becomes very crucial in this context. Now we come to some of the other sources which are non-conventional and non-renewable sources both at the same time. So one of the most important one here is shale. Now, shale gas basically refers to natural gas that is trapped within the shale rock formation deep underground. So, shale gas refers to natural gas. Now, just remember that wherever you see this term natural gas, we mean methane. Natural gas is nothing but, you can say, 80 to 85% nothing but just methane. So shale gas is a form of methane, all right, a form of methane trapped within the shale rock formation deep underground. So if you look at this picture, this is what shale is. So if you look at shale, this is the shale rock layer. This is the layer of shale rocks. So what we do is that we drill a well. We will drill a well that goes until this rock layer, and that is where we start doing horizontal drilling. So we do horizontal drilling, and then a lot of pressure, which is called as hydraulic pressure, because a lot of water is used at high pressure, and with the help of this hydraulic pressure, we try to form cracks. We form cracks in this layer. All right, we form cracks in this layer, and from this crack, these cracks, we get the shale, we get the trapped methane or trapped natural gas, which is brought back to the surface and then used in whatever way we want. So this is exactly what is done in the case of shale gas. So we take the shale rocks, and from there on we do the drilling until that layer, and then we do a horizontal drilling, and then with the help of hydraulic force or hydraulic pressure, we create cracks, and from these cracks, these uh, rocks sorry these gases will be ejected out. So this is how shale is used. Now when you look at shale, and in the context of India, when we look at shale, all these areas that have been marked in blue, all these areas that you see marked in blue, these are the areas where in India we have found shale gas. These are the areas where we have been able to detect shale gas. And all the other areas that you see marked in orange, these are the areas where we have seen prospective or a potential for uh, shale gas. So this there was a research that was conducted by ONGC, and this map more or less was also published by ONGC. And during 2011 to 2021, they did extensive research trying to find shale, trying to find the shale resources in India. And they found all these areas. But at the same time, they also said that the shale resources that we have, it's not of the best quality, and it's not a lot. So we cannot see it. We should not be very excited about shale. Yes, it can be used as an additional source, but at the same time, many of these sites they do not have abundance, and uh, will be basically wasting more money than what we are getting. We'll be wasting more energy into the entire process than the energy that we'll be getting. It would be like you are spending 100 joules of energy and you are getting 80 joules of energy. Then what is the point of getting that 80 joules of energy? So that is what ONGC said, that many of these sites are not that great sites. Because when you look at shale, understand the importance of shale and why are we even studying about shale. When you look at US as a case study, US used to be a net importer of energy, meaning that they did not have enough energy and they used to import energy, import coal, import oil, and take care of all the requirements of energy that they have. But then US discovered shale, and with the discovery of shale, they became a net exporter of energy. So just understand the vastness of shale resources that US was able to find. So US found shale resources, Argentina found shale resources, China found shale resources, Russia found shale resources, and then there are other countries which also found shale resources. So the North and the South Americas and parts of Asia and Europe, we found a lot of shale resources, and that's why shale then for a lot of these countries became one of the primary sources of fuel for them. All right, became one of the primary sources of fuel for them. So even we were excited that there are chances that we would also have shale, and yes, we did find shale resources. But ONGC said that it's not a lot, and we should not be very excited about the shale resources. There are some of these areas which can be used to extract shale, and it can be used as additional source. But we do not have a lot. We cannot compare ourselves to many of these countries that I just listed. Now, when it comes to shale, there are certain issues also with shale. So, for example, it increases the consumption of fresh water. That for providing that hydraulic pressure, we need a lot of fresh water. A lot of fresh water will be inserted inside the well to create those cracks. So that's why increases the consumption of fresh water. Then it can also lead to induced seismicity, earthquakes, because you are in a manner you are creating imbalance inside the earth, instability inside the earth. So this can lead to seismic activities. So that is also a possible outcome. Then potential ground and surface water contamination. Why? Because this fresh water that we are using for providing hydraulic pressure, this fresh water is mixed with a lot of chemical additives as well. A lot of chemical additives are also there. So because of that, what happens is that when it mixes, or if it mixes with groundwater, if it mixes with surface water, it can potentially contaminate ground and surface water as well. That's another problem. And then there are local impacts. There are local impacts, meaning that all of a sudden, let's say uh, the government is able to locate source of shale in a very highly populated area or very highly household kind of an area. Do you think that the government will let go of such an area? Any government in the world, will let go of such an area. No, they will try to extract everything that they can from these kind of areas, and then it creates local impact. So the people who are living nearby, a lot of movements of machinery and transportation, etc., will happen. A lot of dust, etc., will start popping up from here. So for these people, it will become an unlivable situation. So that's why a lot of local impacts are there. And in the US, you'll find that there are a lot of litigations against a lot of these companies which are in the market of shale gas. Wherever this has happened, people have just lodged cases, and there are cases running against these companies. So that's why there are these issues that we have with shale. Then we have something called as coal bed methane. Now, what do we mean by coal bed methane? Now, coal bed methane, meaning that this is methane that we find in the coal beds. Methane that is found in the coal beds, meaning wherever you have coal resources. So, for example, let's say wherever we have the coal mines, wherever we have the coal mines, there are chances that trapped methane could be found nearby those areas. So that kind of methane is called as coal bed methane. Now, extracting coal bed methane is far easier, because if you look at this, as you can see that for getting shale, we have to go much deeper. Whereas for getting coal bed methane, it is very near the surface. So getting coal bed methane is much easier alternative as compared to shale. Very cheap as compared to shale. So now what we see is that the government of India is also working on a plan for coal bed methane as well. So if you look at Indian map, you'll see that these are the areas where we have been able to find the areas related to coal bed methane. So for example, all the areas that have been marked in red, these are the coal fields of India. These are the areas where we have found coal. And all the ones which are marked in yellow, as you can see, many of the adjoining areas marked in yellow, here. So all these areas marked in yellow, these are the areas of coal bed methane. These are the areas where coal bed methane blocks have been awarded. So uh, what we have seen is that, especially in the last couple of years, although it has been in the discussion for a very long time, especially in the last couple of years, we have seen that our focus on coal bed methane has risen. We have been trying to do a lot with coal bed methane, and we now have new projects coming up where we want better extraction of coal bed methane, because we understand that it can become a uh, very big source for us. So, for example, if you look at this news, this is January 2024 in the Economic Times. India's coal bed methane production hits 486.7 uh, MMSCM. MMSCM, when we say, it is basically we are talking about million metric tons of coal bed methane. So natural gas production edges higher. So what we have basically seen is that overall, India's production of coal bed methane has gone very high, and we have seen that there are various different plants and there are new blocks that have been awarded. And for that very purpose, because of that very the thing that we see is what we see is that coal bed methane is actually being produced at a larger quantity as compared to what we saw in the past. And especially, we have seen in the last couple of years, we have seen that it has been increasing further. So that's why this is very, very important from the perspective of coal bed methane. And we see that a lot of importance is being given of late to coal bed methane. Now, the next source is methane hydrate. Again, a source from where we can extract methane. Correct? Again, a source from where we can extract methane. Now, when we say hydrate, can you tell me what is the meaning of hydrate? What do we mean when we say hydrate? Any idea? Anyone who can tell me? Yeah, it is related to water. That is correct. But when I say water, all right, when I say water, do I mean that it has to be liquid in its state? Does it have to be liquid water? No, right? No. So one more question. Can you give me an example? Can you give me an example of a compound which is hydrate, and it is something that I'm very sure that every one of you have in your homes. You are using it, more or less every one of you is using it. Can you tell me, can you give me an example of an everyday item which is a hydrate? Yes, Ananya, you have given the correct answer. Chanchal, you have given the correct answer. Ravi, you have given the correct answer. A very simple example is your washing powder. Washing powder that you're using, it basically it is a hydrate structure. It is not liquid, correct? It is not liquid, but you when you mix in water, it completely dissolves in water. So it is a hydrate structure. So when you say hydrate, hydrate necessarily need not be liquid. It will be in its crystal form. It can be in its crystal form. So as you can see, the crystal of methane hydrate. So methane hydrate crystals are largely found in a lot of places in the world. So for example, if you see sediment and sedimentary rock units below the Arctic permafrost, sedimentary deposits along the continental margins, deep water sediments of inland lakes and seas, under the Antarctic ice. So these are four primary places where methane hydrates can be found. Now, if you see this, all the areas which have been marked in pinkish color, these are the areas where we have been able to find methane hydrates. So methane hydrates are found in all these areas: Arctic and the Antarctic areas, continental margins, and deep inland seas and lakes, or even inside the oceans. So these are the areas where methane hydrates are formed, and this is where we can extract methane from. Now, there is a concept that I used to explain, but I've stopped explaining because it came in your prelims paper. This was a question. This was the question that was asked in your prelims paper. Read the question, think of what the answer should be. Or let me, okay, I'll launch a poll for you, and then I'll explain a very important concept with the help of this question. This was asked, I think, in your 2020 prelims paper. I'm launching the poll. Please mark your answers. And after that, I'll tell you what I wanted to discuss. Is salt a form of hydrate? We'll discuss this. Remind me when the class is about to end. We'll discuss something about salt. So as I say, see that there's a mixed response. 39% A, 24% B, 16% D, 21% D. So let me discuss a very, very important point about methane hydrates. So question says, which of the following statements are correct about the deposits of methane hydrate? First is global warming might trigger the release of methane gas from these deposits. Is it possible? Yes, it is possible. Because what we discussed is that a lot of methane hydrates are found in the Arctic and the Antarctic areas. Now, what's happening is a lot of these methane deposits are they were buried deep under the ice, all right, deep under the ice. Now, what is happening is that because of global warming, we know that polar ice caps are melting. And with the melting of polar ice caps, what's happening is that this methane hydrate is now coming to the surface, and much of the methane is also going and mixing with the atmosphere. Now, methane, just remember this, methane is a greenhouse gas. I'm sure many of you know this, but if you don't, methane is a greenhouse gas. And methane is a more potent greenhouse gas as compared to even carbon dioxide. It's far more dangerous as a greenhouse gas as compared to carbon dioxide. 25 to up to 80 times more dangerous as compared to carbon dioxide. Now, what's happening? That methane is going and mixing with the atmosphere, meaning that the concentration of methane, a greenhouse gas, is increasing in the atmosphere. It will lead to more greenhouse effect, meaning that it will lead to more of global warming. So, what's happening? Global warming is triggering a lot of global warming. Global warming is accelerating global warming because of these kind of events. So global warming might trigger the release of methane gas from these deposits is correct. So that's why in a manner global warming accelerates global warming because of this. Then second is large deposits of methane hydrate are found in Arctic tundra and under the seafloor. We discussed this, that sea bottoms, lake bottoms, ocean bottoms, Arctic, Antarctic and continental margins. These are the areas. So this is correct. Third is methane in atmosphere oxidizes to carbon dioxide after a decade or two. Correct or wrong? This is also correct, that this happens, that this methane that we are talking of, that methane goes and mixes with the atmosphere. Now this methane remains as methane for largely 8 to 12 years. And after 8 to 12 years, it starts to decompose. It starts to change. It starts to oxidize. What happens is that you have methane. Methane now mixes with oxygen that we have in the atmosphere, and then it converts into carbon dioxide and moisture. This is what happens. So if you are also a fan of balancing the equations, please do that. I can't live without it. So this is the reaction. This is the reaction that will happen in the atmosphere, that methane mixes with oxygen, reacts with oxygen, and forms carbon dioxide and moisture. So ultimately what's happening here is that methane is converting into carbon dioxide, correct? Methane is converting into carbon dioxide. So this is something that also happens. Saying after a decade or two is a lot. Largely it happens in 8 to 12 years. Largely it takes 8 to 12 years for this to happen. So the third statement is also correct. So correct answer, that's why, will be 1, 2 and 3. So just remember one important point about methane hydrates, that a lot of methane is actually going and mixing with the atmosphere because of global warming, and that's why global warming is leading to more of global warming. Then lastly we have HCNG. HCNG stands for hydrogen enriched compressed natural gas. Now, when we say HCNG or hydrogen enriched compressed natural gas, meaning that we are mixing hydrogen to compressed natural gas. Now, what is compressed natural gas? CNG, something that you might have heard of in Delhi NCR especially. CNG is used instead of petrol and diesel in many of the vehicles. So, mixing hydrogen with CNG. Why? So, combines the advantages of both hydrogen and methane. How? What is the advantage of hydrogen? What is the advantage of hydrogen? Hydrogen, first and foremost, very, very important, is clean. Clean combustion, correct? No carbon dioxide, no greenhouse gas, nothing. So hydrogen burning is clean. So that is the first advantage, that it reduces the pollution. It will reduce the pollution. CNG is very clean in itself, but still there are some emissions. But even that emission, even that small amount of emission can be reduced further when you use hydrogen. So that's why hydrogen. And just understand, it's not only about CNG. Today you see so much of discussion around hydrogen. We are talking about green hydrogen. We are talking about hydrogen as fuel. We are talking about hydrogen being used everywhere. So why hydrogen? What is the advantage of hydrogen? Why are we mixing hydrogen in CNG? Why are we talking about green hydrogen today? Why do we want to run our vehicles on hydrogen? Why do we want our steel industries to run on hydrogen? Why hydrogen? So, first important thing, clean combustion. Very important. Secondly, abundance. Hydrogen is abundant. There are so many sources. You can derive from petroleum, you can derive from water, you can derive from so many compounds which have hydrogen in them. We talked about hydrocarbons. The world is full of hydrocarbons. You just pick a hydrocarbon, maybe you can extract hydrogen out of it. Hydrogen in its elemental form is the 10th most abundant element on the earth. So hydrogen is abundant, so you have a lot of hydrogen available to extract your fuel from. So clean combustion, abundance, and then efficiency. Let me write high efficiency, meaning that per unit volume of hydrogen, you get more energy as compared to many of the other sources. So because of these three are the most important advantages, I would say, of hydrogen. Because of these three most important advantages, that is the reason why we want entire economy to run on hydrogen. Why we are talking about so many different ways of using hydrogen. So that's why hydrogen. So HCNG is this, where you are combining hydrogen, you are mixing hydrogen with CNG. What are the advantages? First, it reduces the emission of carbon monoxide and other gases as well. So emissions will be lesser, but not zero, right? Not zero emission, because you are still using CNG. It's not that you are using pure hydrogen. Emission will be zero when you are using pure hydrogen. But here you are mixing hydrogen to to CNG, and hence it will just reduce the amount of emission. Second is enables fuel saving, efficiency is higher. Engines can be calibrated to release lower amount of nitrogen oxides as well. So that is also advantageous. Less air pollution, that means. Engines need minimum modification to run on HCNG. That you do not need to change your vehicles. You do not need new vehicles. You can make the modifications, slight modifications in the configuration of the vehicle itself, and that will do. And then ideal fuel also for high load applications and heavy duty vehicles. Now this is very, very crucial. All right, this is very, very crucial, because it means that when it comes to CNG, you might have seen that CNG is being run for cars, for auto rickshaws, etc. HCNG can be used for buses and trucks as well. It can be used for buses and trucks as well. That is an advantage, that you can run the buses on HCNG. And this is something that has been tried. There was a pilot that was done, a pilot program. A pilot program has been done in Delhi back in 2020, where some of the buses were chosen, and these buses were run on HCNG for a few months, just to understand CNG, understands the goods and the bads of CNG. So HCNG. So that's why we already have done this. We have already run a pilot program in Delhi with HCNG, understood some of the problems, understood some of the disadvantages, etc. as well. So we see that there are all these things. So performance altogether, better performance of hydrogen itself is very, very crucial advantage of what it adds to HCNG. But there are limitations. What are the limitations? First, determining the most optimized hydrogen to natural gas ratio is not that easy. Knowing how much of hydrogen should mix with how much of natural gas is something that we are still trying to figure out. Now, although we have used it, as I told you that in 2020 we have run a pilot program, but we do not know that whether that was optimum, whether that was the best ratio that we could have used. So that's something that we still need to evolve on. We still are trying to figure that out. Then requires new infrastructure for preparing HCNG. You need a lot of units to come up, correct? These units that can prepare HCNG, we need that. So one of the points. Then many steps are also required for commercializing it at a larger scale. Because Until now, we have just run a pilot program. We have to figure out how to make it large, right? We have to find a way in which it can be commercialized, it can be used at a very large scale. So that also is one of the things. And then the problem of the cost of hydrogen. That is the problem, not only in HCNG, but largely everywhere. We know the advantages of hydrogen, but why aren't we using hydrogen everywhere? Cost. Manufacturing hydrogen is very costly. So, what does it mean? Manufacturing hydrogen is costly. So, that's why getting HCNG is costlier. So, that's why HCNG will be very costly as compared to CNG. So we have to find ways in which we can lower the cost of hydrogen production so that we can lower the cost of SCNG. Otherwise, SCNG is going to be costly. And suppose that if the public buses are running on HCNG, either the government will have to subsidize everything so that the uh, cost for the consumer does not rise. If not, then the consumer will be paying higher prices. Now, that is not ideal, because if somebody is traveling in the public transport, a very important reason also is to save money. But if they are not saving money, why would they? They would be discouraged from getting on those buses. And that's something that the government would never want. So that's why we need to find ways in which we can reduce the cost of hydrogen production so that we can reduce the cost of HCNG. So that's why these are some of the limitations. Let's not call disadvantage, but rather let me say that these are some of the limitations. Right? So that's why this question, this was also asked in your paper. Please read the question and then I'll launch the poll for you. It's a very easy question. I hope that you get it correct. Hmm. So 50% of you have marked B, which is the correct answer. If you are confused, let me give you the answer. In the context of proposals to use of hydrogen enriched CNG as fuel for buses and public transport, consider the following statements. First, the main advantage of the use of HCNG is the elimination of carbon monoxide emission. We have a strong word here. We have an extreme word here. And what we discussed about extreme words is that wherever you find an extreme word, be cautious. Did I say elimination of carbon monoxide? Let me go back to what we discussed. Reduces. Reduces the emission of carbon monoxide. It cannot eliminate, right? It cannot eliminate. Eliminating is what? 100% reduction. That can't happen because you have CNG, and elimination cannot happen because of that. So that's why elimination is wrong. Reduction is correct. It reduces it by almost 40%. So this is wrong. One is wrong. So one is wrong means that A is not the answer and D is not the answer. So either it's 2 and 3 or it's 4. So let's look at 4. 4 says HCNG makes the fuel less expensive than CNG. Wrong. We discussed just now that hydrogen production is costly. So HCNG is costlier. So that's why 4 is wrong. So 4 is wrong means that C is gone. So whether you have read stream number 2 and 3 doesn't matter. Statement 2 says HCNG as fuel reduces carbon dioxide and hydrocarbon emissions. Of course, it will, because you are using hydrogen, that reduces the emission. Hydrogen up to one-fifth by volume can be blended with CNG as a fuel for buses. This is a very, very difficult statement. And in the absence of elimination that was possible in this question, I don't know how to mark this answer correctly, because this third statement was a very difficult statement. So sometimes that's why you have to be mindful. I know that in the last couple of years, UPSC has done something different. In the pursuit of doing something different, they have now questions where they say that only one statement is correct, only two statements are correct, and those kind of questions. So if this was that kind of a question, it would be an extremely difficult question to answer. But with elimination, which was available thankfully in this question, it's an easy question to answer. So I expected more of you to answer this question, because the first and the fourth statements are exactly what we already have discussed just 5-10 minutes back. Right. So any question that you have from here until now, whatever we have discussed in last 1 hour or so, any question? Hydrogen is not toxic gas. No, toxicity wise, hydrogen does not belong there. So it's very safe compared to many of the other gases. Maps important for science. Not for science. See, it's not. It's the context of the question. If the question talks about regional specifications, then maps are important. Otherwise, it depends, right? It depends. I'm stuck with extreme words. Could you please provide the list of extreme words? See, there are a lot of extreme words. So, for example, all, none, completely. What else? Elimination in this context was then every. So, these kind of words, right? These kind of words. Only, we had seen in the last question, only. So, wherever you find these kind of words, they will be called as extreme words. Is India lagging behind in creating adequate CNG units all across India by looking at the crowd which is there for HCNG? Uh, I would I would partially agree with it that the model that we introduced in Delhi, we could have introduced similar models in other parts of the country as well. And there were chances that we would have done that. We still see that air pollution is a big contributing factor, and in that air pollution, vehicular pollution is a big factor. So yes, I would agree with what you're saying. Yeah, always. So many of you are also adding to the list of uh, these extreme words. What's the main difference between CNG and HCNG? Hydrogen. Hydrogen is the main difference. In 2023 prelims, the statements which contained some were found to be correct. In most of the cases, this will happen where you have these kind of milder words like some, maybe, can be. All these kind of words often are correct. So that helps them generalize a lot of things. Why don't really more CNG if it is less expensive? See, it's entirely about the infrastructure that we needed to build, the one that we need to build, the kind of money that we need to spend in building that infrastructure, uh, the difference that will come in, the even the engine modifications that will be required. So that all needs a lot of money, and that has something that has prevented this from going in the direction that it should have gone. Is it used in aircraft carriers as well at CNG? See, it's in a very nascent stage, so right now, no. Leaderboard. So, leaderboard for the day. This is the leaderboard. Yeah. So, this is the leaderboard for the day. Hmm. So, so congratulations to everyone who has gotten all correct. I'll send you my address. Please send me sweets. But for everyone else, just understand where you went wrong so that you do not commit the same mistake again. Salt, remembering about the salt is a form of hydrate. Huh. See, salt depends on what kind of salt are we talking about. Generally when we refer to salt, we mean common salt, and common salt is sodium chloride, NaCl. Now, this cannot be called as a hydrate, all right? This cannot be called as a hydrate. But there are others which can be called as hydrates. For example, the salt made of copper sulfate, that can be called as a hydrate because there is hydrogen, or let's say, sorry, water molecules that are mixed with it. So, wherever you have a compound, let's say, which has this kind of a formula, where you have hydrogen, or sorry, where you have water molecules mixed in it, then in that case you can say that it is hydrate. But now what can happen is that many of these can uh, they can also they can also absorb moisture. For example, salt can very easily absorb moisture. So when it absorbs moisture, you can say that, okay, fine, it has become hydrated. But in its pure form, salt is not a hydrate. All right, it is in its pure form, it is not a hydrate. So that is where the difference lies. So for example, when I talked about washing powder, all right, so washing powder is what it is: sodium carbonate, hydrate of sodium carbonate. So washing powder, the formula is Na2CO3 dot 10H2O. So that's why AbNH2O. So that's why it is a hydrate. It is naturally a hydrate. So just understand when we call something as a hydrate. So some salts can be hydrate, but if you are talking specifically about common salt, that is sodium chloride, then in its pure form it is not a hydrate. But yes, it can absorb moisture. So you can say yes, it has components of moisture. Can you make a comparison between petrol and CNG? See, petrol basically is hydrocarbon, a complex mixture of hydrocarbon, a petroleum product, whereas CNG is compressed natural gas. And as I told you, that when we say natural gas, we mean methane, correct? We mean methane. So it's a form of methane. It's a compressed form of methane, whereas petrol is a mixture of various different hydrocarbons. That's the most important difference. And so both are used as fuel. Uh, you can say that CNG is much cleaner as compared to petrol. So there are all these things where they are different. Yeah, you can say that the power that can be generated, that's higher with petrol as compared to CNG. What is the source to refer for science and technology? I would say largely current affairs, and all the static areas required is what I'm covering here. So what I'm covering plus current affairs plus those NCRTs. That's it. Are you always available at your email ID? Yeah, I try to be as available as possible. So if we have any doubts regarding the subject, can we ask there? Of course you can. Please send your address quickly. Uh, Thank you for even asking. Geography faculty provided us their number. Can you give this? It's very, very difficult for me to do that because I am very horrible in using my mobile phone, and a lot of you will not see me picking the call. So that's why I've stopped doing that. Gypsum, yes, gypsum is also a hydrate, so correct, because it makes plaster of Paris from there on. What should I do after the class? Just go and revise. Sulfonate is an example of hydrate. Yes, you can say that. You said methane is dangerous, so CNG is also dangerous. See, what happens is that here CNG has methane, but combustion of methane happens, and combustion of methane means again the same process. That is methane mixing with mixing with oxygen to form carbon dioxide. So what is emitted is not methane but carbon dioxide. So emission of carbon dioxide happens, not methane. Should I make notes while it's studying NCRTs? I would actually say no. I would say that it's better if you can just highlight or underline there, because it's not that a question is expected to come out of those areas. It's just for your basic understanding. In which chapter shall we discuss AI? In the chapter called AI, we'll discuss it there. Uh, I missed some questions, is it? Webinar, I mean, the science webinar, I have just recorded and I've given it to the team to upload it, and it will be available for you. I told it earlier also, I did not do it live because I had to show a video at a certain portion, which is not possible in a live session. It's possible in a recorded session. So that's why I recorded the session, and I've sent it. Not uploaded yet. It will be uploaded. I was told that it will be uploaded today, tonight. Uh, Probably after the session, sometime it will be uploaded. Don't worry. And the recordings will be available anyway. Social media. I rarely use any social media. I'm a working professional. How much time is required for preparation for 2025? See, it actually depends on the candidate. So it would not be wise to even suggest that these many hours. But overall, see, on a daily basis, or let's say on a weekly basis, I would say that somebody should at least have 25 hours of time, maybe 3 hours a day on your weekdays and a lot more time on your weekends, but you'll have to give 25 to 30 hours in a week to do a holistic preparation at least. When you ask the team to provide updated schedule for upcoming subjects, I'll check with them. I'm not sure because some of you also wrote that you had received something for polity, but I am not sure of it, so I'll discuss this with them. You said that coal can be in gaseous state also. No, I did not. Coal gas. No, coal gasification is when you are converting coal into gas. It is not coal anymore. It is a mixture of carbon monoxide and hydrogen. It's not coal anymore. So that's different. Could you please make science and tech webinars once in a week? That will be difficult. But at the same time, see, there are news analysis that we are doing, and there also I have been taking at least half of the sessions there. So we keep picking all the science and tech topics there as well. And in the webinars, because in the monthly webinars, what happens is a lot of filtration happens. and then you get the best of the topics, the important topics. Otherwise, many of the topics, they lose their importance after a week. It looks to be important, but later it is not important at all. So it's better with the monthly sessions. Right. So I think I've answered most of the questions. We could extract hydrogen from coal gasification. Yes, we can. I mean, we can derive hydrogen from coal. That is called as black hydrogen. Just like we have green hydrogen, similarly, when we extract hydrogen from coal, we call it as black hydrogen, because, of course, I mean, it's coal, combustion happens, carbon dioxide emission. So that's why black hydrogen. Hmm. So anyway, so it's almost time. So let me not start new topic. Let's begin with a new topic that will be renewable energy sources. We'll discuss tomorrow. So again, my email ID I had given, and I'm just writing it again for any questions that you might have. rasesh.kumar@byju's.com. All right. So thank you very much. Good night. Please go back, revise everything before coming back tomorrow. And if you have any doubts with whatever we discussed today, please write to me, or maybe you can bring the question tomorrow and we can discuss those questions tomorrow as well. So with that, I'll take your leave. Thank you very much for being here.